So, in this video, I'm going to explain you the basics of blockchain. Albert Einstein once said, if you cannot explain it simply, you don't understand it well enough. So in this video, I'm going to try to explain you blockchain very simply, in very simple words. So let's start. Now let's assume that Elon and Bill are roommates, and there is no connection to Elon Musk or Bill Gates. It's just coincidence. So Elon and Bill are roommates, and they decide to split their expenses every week. So every week they do their expenses, and in the first week, assuming Bill has to pay Elon $10, $10. So Elon is the record keeper. Bill pays Elon $10 on week number one. In the second week, because they are roommates, Elon is again being the record keeper. Elon has to pay Bill $15, but Elon is a cheat. So instead of paying $15, he changes the record to be $12 so that he has to end up paying Bill $12. Bill gets suspicious. Now, Bill also starts keeping a record without telling Elon. At the end of week 3, Elon has to now pay Bill $10, but then he is a cheat. He changes the records again from 10 to $8. So Elon now has to pay Bill $8, and now Bill says, I have a record, and as per my records, it is $10 and not 8. They compare records, and Elon is caught. And then they have another roommate coming in, Jeff. There is no connection to Jeff Bezos here. Now, Elon in the fourth week has to pay Bill $20, and because now it's a norm that everybody keeps their own records, both Bill and Jeff have the same record where Elon pays Bill $20. It matches, all is well. Next week, Elon has to pay Bill $30 and Bill has to pay Jeff $10. Again, Elon is a habitual liar, so he again changes the record from $30 to $20, but he only changes his. He cannot change the record for Bill and Jeff. So the majority wins. Elon ends up paying Bill $30 because the record from Bill and Jeff match. Very simple. This is a general, very generic use case on roommates maintaining their expenses. Essentially, what they did was they formed a network wherein Elon, Bill, and Jeff have their transactions noted, and they have their own copy of the ledger. And this is the ledger. These are the top two characteristics of blockchain. There are more which we are going to discuss, but a peer-to-peer network, that means there is no record keeper, there is no centralized entity. Elon was the centralized entity in the first week, but then it was decentralized because Elon started cheating, and a replicated ledger. So everybody have the same copy of the ledger with them, right? Now, let's move on and understand more. Now, Bill, Elon, and Jeff, they started their own business of gold mining. Second use case, they start their own business of mining gold, diamonds. So they are mining diamonds. Because this is more complicated, Elon planned to be the record keeper once again, but this time he is using his computer to keep records. So the first day, the first week they started mining, he kept the record like that. Block number, that means entry number 0, nuns, assuming this is a random number for now, but it has value, so we'll come back to it later. Nuns is a number, that is associated with the transaction. So we're going to talk about that later. You have data, that means they have mined 5 diamonds. Based on the nuns and diamond, a hash is created. What is a hash? Hash is a cryptographic key. So based on this 5 diamonds and nuns, they create a hash which is 0xabc. It's a hex, cryptographic key. For Bitcoin, they are using SHA-256. Other networks, they use their own cryptographic algorithm. So hash is a combination of a key based on nuns and data. If you look at, there is another one, previous hash. Because this is the first block, it does not have a previous, therefore it's all zeros. The second week, the block number 1, so it was 0, block number 1 is created, you have nuns, just a 1-up number, and this time you have 15 diamonds of data. If you look at the previous hash, is the previous block, the previous transaction entry. So 0xabc, 0xabc, and they are linked. They are linked through a chain because the previous hash forms one of the elements to calculate hash. In here, the previous hash was 0. But now you have a previous hash. A combination of nuns, data, and previous hash forms the new hash for this block. Next, week number 3, they have 20 diamonds with nuns, again a 1-up number, data, and previous hash is 0x124, which is 124A. So these are blocks of transactions linked with each other, stored with Elan as a hash cryptography. Because these are diamonds, these are high values, these are more complicated. Now, because Bill and Jeff, based on when they were roommates in the previous case, they do not trust Elan. They also start keeping on their own computer the copy of these blocks. And please note that the first block of the chain is known as Genesis. So Genesis is the first block on the chain. And because these are blocks connected with each other, chained with each other, the concept blockchain. Now, because Elan is a habitual liar, a cheat, he tries to manipulate this record. So let's see what happens. So instead of 15, he changes the entries to 12 diamonds. Now imagine when 12 changes, there is a change. Now the nuns, data, and previous hash produce a new hash key. So now the hash changes from 124A to 125B, for example. Now this hash is linked to the third block, this one. So it does not match, and therefore this also would change. Again, the majority wins. These Bill and Jeff are good guys. They are not changing their data set. These blocks are not matching to this. That means Elan has made changes to this block. This is the concept of hashing algorithms on blockchain. So it basically is a network of computers with their own blocks chained together. As and when new data comes in, it will go on adding onto this chain. So blockchain has these important characteristics. A peer-to-peer network, no decentralized, there is no central record keeper, a replicated ledger, that means everybody has their own copy of the ledger. The ledger entries linked with each other, so they are linked with the help of previous hash. It is linked and forms a chain. It is protected by a cryptographic key, so hash Hashing algorithm is a cryptographic key, and it's a decentralized system. This is the basic concept of a blockchain. Now let's see a little bit technical how it's all come together. So take this example. They are connected set of computers in a network, decentralized, peer-to-peer. So you have peer-to-peer computers with their own set of ledger information. And this network of peer-to-peer computers connected to each other, let's assume this is a network, Ethereum. There could be Bitcoin network. There can be hundreds of networks that are available, but Ethereum and Bitcoin are the top two. Now, Ethereum network, during the time of recording the video, has moved from proof of work to proof of stake. Whoops, what is proof of work? What is proof of stake? That is for the next video. So now you have this peer-to-peer network on Ethereum. The way to connect to the Ethereum network, the way to become a partner on the diamond mining business of Elon, Bill, and Jeff, the way to become a roommate is using Get, Go Ethereum. So Go Ethereum is a client which, when you install on your server, computer, or laptop, will get you a copy of the ledger, the entire blocks which is available on Ethereum, and you become a part of network. You also take part in maintaining those records and creating hashes, generating hashes to create blocks. We are going to discuss that in proof of stake, proof of work concept probably later. So Geth is the client that helps you, your computer, to get onto the Ethereum network. Now, in order to connect, you need an EVM client. EVM means Ethereum Virtual Machine. Ethereum Virtual Machine can connect to this network, and Geth, which is the client written in Go language, helps you connect to the network. Now, you can write smart contract. We're going to discuss that later. You're going to write Solidity, which is the language of smart contract. Again, this is for later. And then the Web3 interface lets you connect with multiple other programming languages like Python using JSON, RPC, IPC protocols, JavaScript, and Java. So all these languages you can write using Web3 interface in order to connect to the EVM clients onto the Ethereum network. So this is the architecture of how you connect to an Ethereum network through EVM client using Web3 interface. Very, very basic. And then in the next video, I'm going to talk to you about what is a local installation of Ethereum, Ganache, and how do you write smart contracts? How do you use Python? How do you use AI? There are a lot of other things that I'm going to discuss in the next set of videos. So thank you for watching.